Live at the Guyana Space Center for the 10th launch this year, and we are orbiting the Mohammed 6A satellite for Thales Alenia Space and Airbus for the Kingdom of Morocco. It's travelling on board a Vega launcher tonight. There it is on the pad inside the top of the launch vehicle, going through the final preparations before launch. That's scheduled in just under 14 minutes time. You can see the countdown there on the top right hand side of your screen. Let's find out now more about tonight's mission and our satellite. Here's Stefan Israel.
Dear clients and partners, ladies and gentlemen, Arianespace is delighted to welcome you at the Guyana Space Center for this new Vega mission, the third this year with our lightweight space carrier, and the 11th since it was introduced at the CSG in 2012. For today's mission, Vega is about to launch the Mohammed 6A satellite on behalf of the Kingdom of Morocco. This Earth observation satellite was produced by the Thales Alenia Space Consortium as prime contractor and Airbus as co-prime. We would like to thank the Kingdom of Morocco for entrusting us with the launch of their satellite for the first time. My thanks also go to Thales Alenia Space and Airbus, two long-standing partners of Arianespace. Vega is on the launch pad right now and the final chronology operations are underway. The launch is imminent. After liftoff, Vega will head north in order to inject the satellite on a sun-synchronous orbit. Separation of satellite Mohammed 6A will take place some 56 minutes after liftoff. I now invite you to share this long-awaited moment of liftoff. Go, Vega. Go, go, go. And safe trip to satellite Mohammed 6A. Enjoy the show.
Stefan Israel, the CEO of Arianespace. Now, the Guyana Space Center is on the northeastern tip of South America, on the Amazonian coast, on the equator. And we can launch any satellite to any orbit from here. To do that, we have 3 different launch vehicles, and for anybody who's unfamiliar with them, Ariane 5 is the big one. It carries the heavy weights. Then the middle weight is the Soyuz launcher, the Russian launcher, and the light lifter is Vega. That's the one that we are using tonight. There it is on the pad. Flight number 11, VV11. It stands some 30 meters tall. That's roughly the same height as a booster on one Ariane 5, and it weighs roughly a third of its big sister, 38 meters tall there. 30 meters tall rather. And if we take a look inside, you can see at the top of the launcher, that's where our satellite is, inside what we call the fairing. That's the pointy nose, if you like, of the launch vehicle. And it's the Mohammed 6A satellite, an Earth observation satellite built by Thales Alenia Space and Airbus for the Kingdom of Morocco, weighing just over 1 ton. We have a number of different control rooms here at the Guyana Space Center. There is only one mission control, however, and we have a number of different teams here. This is the Flight Directorate. This is the team, Arianespace top management, who take all the decisions in the event of unplanned situations. They are focusing hard at this point before the launch. They are in what we call the fishbowl, which is where all the operational teams sit, and all the information comes into the Mission Control Center. Back to the satellite, someone who knows it well is the project manager.
Le
The Vega launch vehicle will inject the Mohammed 6A satellite into sun-synchronous orbit. The Mohammed 6A satellite is an Earth observation satellite built for the Kingdom of Morocco by a consortium led by Thales Alenia Space as prime contractor and Airbus as co-prime. As the system prime contractor, Thales Alenia Space supplied the payload, including the optical instrument, the image transmission subsystem and the ground segment for image processing and production. Airbus was in charge of the satellite, its integration, as well as supplying the platform and the ground segment for mission planning and satellite control. The Mohammed 6A satellite will be used in particular for mapping and land surveying, regional development, agricultural monitoring, as well as the prevention and management of natural disasters, monitoring changes in the environment and desertification. 8 minutes and 45 seconds to launch now. We had the final weather check. That was about 1 minute ago, and the weather status panel is green. And there is Natalie Philippe again here in the fishbowl. This is the program director's desk. The program directors are in charge of the satellite contract for their respective companies. They signed this particular contract 4 years ago, so these teams have been working together on the Mohammed 6A satellite for 4 years. As for the launcher, Vega, well, that is built by the Italian company Avio, depending on your pronunciation, at their plant in Colleferro in Italy. And the motors are made by Safran in Germany and France. All of those sections are shipped here to French Guiana for assembly, and the process of assembling the launcher and the satellite is called the launch campaign. Teams have been working here for 7 weeks to prepare.
The campaign preparation of launcher VV11 began on the 20th of September, with the PAT stage being transferred to the mobile gantry, which is the Vega assembly building. The first phase of this campaign essentially consisted in the mechanical assembly operations with the assembly of the Z23 and Z9 solid propellant boosters, and finally the fourth Avon stage, which was mounted onto the launcher on the 6th of October. The 2 weeks that followed were devoted to electrical and fluid functional tests, which all went successfully. The Mohammed 6A satellite, built by Airbus and Thales Alenia Space, arrived in Guyana from Toulouse on the 22nd of September on board an Antonov 124. The satellite container was then trucked over to building S3B, where the satellite preparation and filling phases were to take place. After the electrical and fluid fit checks that lasted for 3 weeks, the satellite was filled with hydrazine and then pressurized for 2 days by the Ariane Group team from Lampolthausen. The review to start the combined operations was held on Thursday, 19 October. The satellite was strapped onto its PLA 937 adapter by the Arianespace team on Friday 20 October and then encapsulated on the next day. The upper composite, which houses the satellite encapsulated into the fairing, was then transferred to the mobile gantry and integrated into the launcher on the 26th of October. The remaining operations saw to the filling of the Avon tanks. The dress rehearsal took place nominally on Friday 3 November. Apart from the charging of batteries, there will be no more satellite-related operation until launch. The Vega VV11 launcher is now ready to go.
To allow the Vega launcher to take off, its first stage, the PAT, will have to build up 2,200 kilonewtons of thrust. The first flight phases of the 3 solid propellant stages, PAT, Z23 and Z9, will be monitored by the Galileo telemetry station, which will cover the flight for 7 minutes. The last stage, which houses the Avon liquid propellant engine, will proceed to its transfer orbit after an initial boost of 8 minutes. This will be tracked by the telemetry stations Bermuda and Saint-Hubert in Canada. After a long ballistic phase, the Avon will initiate a second 2-minute boost to circularize the orbit, tracked by the new Norcia station in Australia. Once locked into this final orbit, satellite Mohammed 6A will be separated from the rest of the launch vehicle. And that's what's going to be happening over the next just under an hour. And I've now returned to my commentary box in the Mission Control Center, looking down at these boards and these teams. A couple of key people. This is the mission director in charge of the launch campaign. And the range
attention pour la séquence finale lanceur.
Operations manager.
Top, à 0 moins 4 minutes.
He calls out all the major events, and he's just called out the beginning of the last 4 minutes, the synchronized sequence. Computers are now controlling all the final checks in the countdown, and they manage an impressive list of operations. All of that information is sent to these boards. We call these the status panels, and they are representing the 3 main systems across the base: the rocket and pad, the satellites, and the range. And a quick translation for you. The base at the top, logistics, safety. Mesure is the telemetry. Localization is radar. Telecoms, obviously. Ensemble de lancement is the launch, the range. And then, of course, the Vega launcher, the weather, and our satellite. The teams in the Launch Control Center are watching over all of these operations. The Launch Control Center is based close to the pad, about roughly 1 kilometer. And they're in a protected blockhouse. And they are, of course, concentrating hard at this point just before the launch. Once Vega has lifted off, it will take approximately 55 minutes to deliver the Mohammed 6A satellite to its orbit in space. And after that, the satellite will continue orbiting on its own, on a sun-synchronous orbit. 2 minutes now, Vega standing tall. We have 3 working launch zones here at the Guiana Space Center, 1 for each rocket. And this is the Vega launch site. It's called SLV, Site de Lancement Vega. It was built on the first Ariane launch pad. That was Ariane 1, which launched on the 24th of December 1979. Some of you will remember that. The final countdown started just over 9 hours ago. The mobile gantry was withdrawn about 3 hours and 15 minutes ago. It took 45 minutes to do that. Coming up to 1 minute.
À 12 de DDO, attention pour moins 1 minute. Top, à 0 moins 1 minute.
We are 1 minute to launch. Our very best wishes to all the teams, to the Mohammed 6A satellite teams and the Kingdom of Morocco, to the industrial consortium led by Thales Alenia Space and Airbus, and to the teams on the ground who are waiting to take over the satellite. Let's sit back now and watch the launch. Our very best wishes.
À 12 de DDO, attention pour les 2 comptes finales. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. À image P80, décollage.
We are off. The Mohammed 6A satellite is on its way. Vega number 11 is blazing a trail across the equatorial skies over the Guyana Space Center. He's telling us the propulsion is normal. We're heading direct north, out towards the Caribbean. We broke the sound barrier and reached Mach 1 after 30 seconds. Picking up the signal at the station in Saint-Jean-du-Maroni, which is here at the Space Center, or just outside it. We can hear the rumble of Vega reaching us. The job of the first 3 stages is to get us away from the Earth. Vega is pushing itself away from gravity. And we need a lot of firepower to do that. We're burning the P80 first stage. P for premier étage. It's all going normally according to plan. Premier étage means first stage. 80 is the mass of propellant. Roughly, it's actually 89 tons. Bottom of the screen, our altitude on the left, 53 kilometers above Earth. Our distance is a straight line if you were to draw a straight line from the pad. And here we are separating the first stage, it's burnt its fuel, and we've switched on now the second stage. The Z23 burns for about 1 minute and 40 seconds. Z for Zefiro, which is an Italian wind, a bit like the Sirocco or the Mistral. 23, because it burns 23 tons of solid propellant. Our speed on the bottom right, nearly 3 kilometers per second, not per hour, per second. We're getting close now to what we call the Kármán line. That's 100 kilometers above Earth. We've just hit it. It's named after the Hungarian-American engineer, aerospace engineer, Theodor von Kármán, and it's the border with space. Basically, the higher you go, the thinner the atmosphere becomes, and the faster an aeroplane has to travel to stay up. Once you get into space, the air's too thin to support wings. And top right-hand side is the trajectory, showing us the flight path, if you like, and the white cross is the actual position of the launch vehicle.
Séparation Z23.
Separation of the Z23. Ignition of the next stage coming up, the Z9. There it goes. And then we can expect the fairing, the nose of the vehicle, to fall away. So we no longer need the fairing because we are effectively in space. We don't have enough friction anymore to cause us any difficulties, so the satellite is safe to be exposed to space. Now, Vega is particularly well suited to launching Earth observation satellites. This is the 23rd one to travel on board this versatile light launcher. And there are 9 more in the order book. Over now to the manufacturer, Avio.
The Vega launcher is the smallest of the European launchers operated by Arianespace. It has set a world record for small launchers in terms of precision and reliability, with 10 perfect launches in a row from its maiden flight. This high level of confidence has led Arianespace to recently sign a new contract for 6 Vegas and 4 Vega Cs for a total of 10 flights to occur between 2019 and 2021. I am now in our plant in Colleferro, where we produce both Vega and the boosters of Ariane. Here we are developing Vega C, which will fly for the first time in 2019. Behind me you see the first Zefiro 40 solid rocket motor ready to be sent for static firing test. The Zefiro 40 motor is the second stage of the new Vega C and is nearly 8 meters long, has a diameter of 2.3 meters and contains around 40 tons of propellant. The loaded case will be sent soon to the test bench for static firing. The Avio team, together with its industrial partners, Arianespace and ESA, are ready to demonstrate the strengths of Europe's collaboration in the space industry. I therefore wish the best success to the 11th mission.
And the first 3 contracts for Vega C are a constellation for Airbus, an Earth observation satellite, and a Cosmo SkyMed second generation, which was also built by Thales Space. Separation now of the Z9 third stage. So the main propulsion phase of the flight is now over. We've got away from the Earth, and the upper stage, the AVUM or AVUM, is getting ready to switch on its engine in roughly 1 minute. The flight path takes us north, heading up over the Caribbean, along the east coast of the US and Canada. And we cross the Arctic and come back down to the west coast of Australia. And he's announcing that we are picking up the signal at the ground station in Bermuda. It's a Caribbean island, and we're using telemetry to track the vehicle. During the flight, Vega sends information to ground stations along its path. And they send that data here to the teams at the Guyana Space Center, which allows Arianespace to monitor the flight in real time. So the AVUM upper stage is waiting to switch on its engine. Here we go. Scheduled. And we have confirmation that the AVUM upper stage has now switched its engine on for the first of 2 burns. It's going to burn for nearly 8 minutes. So we started the next phase of the journey. Observation from space is vital for helping us to better understand our planet, and the Mohammed 6A satellite will play an important part in that. Morocco is a modern society focused on the future with a very real commitment to environmental principles. And of course they hosted COP22 in Marrakesh this time last year. And if you've been to Morocco, you will know that it is a truly magnificent country with mountains, beaches, deserts, and it has a rich and important biodiversity and a long cultural history spanning several thousand decades. It's blessed with breathtaking landscapes. Live at the Guyana Space Center for the 10th launch this year, and we are orbiting the Mohammed 6A satellite.